Have you ever wondered how those icy golf balls from the sky, known as hail, come into existence? Hail is a fascinating weather phenomenon that begins its life in the tumultuous environment of strong thunderstorms. Within these storms, unstable layers of air set the stage for hail formation. It all starts with the creation of an ice core, hidden high in the cold reaches of thunderclouds. This tiny ice nucleus is destined to grow, layer by chilly layer. So, hail begins as a tiny ice core, much like a small seed that's about to embark on an incredible journey. Imagine being tossed up and down repeatedly inside a giant freezing cloud. That's the life of a developing hailstone. The formation of hail begins with a small ice core, not unlike the tiny grain that initiates the growth of a pearl in an oyster. This core forms in the cold, high regions of thunderclouds, where temperatures plunge below the freezing point. As the hailstone begins its journey, it encounters the dynamic forces of updrafts and downdrafts, essential players in the theater of the skies. Updrafts, those powerful rising air currents, lift the fledgling hailstone up through the cloud. Here, in these frigid heights, water vapor condenses and freezes on the ice core, adding a fresh layer of ice. Once the updraft loses its strength, the downdraft takes over, sending the hailstone plummeting downward. But this descent is not a fall to the ground, it's part of a cyclical voyage. As the hailstone travels up and down, it repeatedly enters colder zones of the cloud. Each journey upwards allows it to collect more water, which freezes, thickening the ice layer by layer. This process is akin to how an oyster wraps layer upon layer of nacre around a grain of sand, gradually forming a pearl. This turbulent, repetitive journey builds up the hailstone layer by icy layer until it's too hefty to stay airborne. Each layer marks a cycle completed in the stormy realm of its birth, a testament to the power and complexity of our atmosphere. What happens when a hailstone becomes too heavy for the cloud to handle? As hailstones journey through the sky, they grow layer upon layer, much like pearls slowly accumulating in oysters. But unlike pearls, hailstones have a tipping point. Once they gain enough weight, the cloud's updrafts can no longer support them. The size of a hailstone is a testament to its turbulent path within the cloud. Each ascent and descent through updrafts and downdrafts allows it to capture more water, which promptly freezes, adding to its girth. This cycle repeats, the hailstone getting larger with each loop through the cloud. As the hailstone enlarges, it reaches a critical mass where the updrafts, no matter how strong, cannot counteract the pull of gravity. At this critical juncture, the hailstone detaches from its aerial carousel and begins its descent towards the ground. The size of the hailstone at this point can vary. Some remain pea-sized, while others grow as large as grapefruits. Eventually, gravity wins, and the hailstone plummets to the earth, sometimes reaching impressive sizes. Not every thunderstorm births hailstones. So, what magical recipe does nature follow to cook up a hailstorm? The formation of hail is a complex dance between temperature, air currents, and humidity. First and foremost, the temperature within the thundercloud must dip below freezing. This transforms water into ice crystals, setting the stage for hail to begin its formation. Strong vertical air currents known as updrafts and downdrafts play a pivotal role. Updrafts whisk these ice crystals upwards where they encounter even colder temperatures and gather more moisture. This moisture freezes, adding layer upon layer to the hailstone, much like an oyster wrapping layers around a grain of sand to form a pearl. Meanwhile, downdrafts send them plunging downwards, only for updrafts to catch them again in a relentless cycle. Geographic location and seasonal weather patterns also heavily influence hail production. For instance, in temperate latitudes, hail is more likely during the colder months, while tropical regions might experience hail year-round, often intensifying during warmer months. Understanding these conditions helps meteorologists predict when and where hail might occur, although nature always holds some surprises. So we've traveled through the chilly, tumultuous life of a hailstone today. Let's briefly revisit the incredible process that brings about this icy phenomenon. Hail begins its formation in the unstable layers of air typical of strong thunderstorms. Here, the dance between updrafts, which are rising air currents, and downdrafts, the descending ones, plays a critical role. These air movements whisk the tiny ice core up and down within the cloud. As the core ascends, it encounters freezing temperatures well below 0 degrees Celsius. This is crucial because it allows the water droplets surrounding the core to freeze, adding layer upon layer to the hailstone, much like an oyster forms a pearl. High humidity levels also contribute, supplying ample water vapor that freezes into additional ice layers. Remember the pearl analogy? Just as a pearl grows inside an oyster, A hailstone develops within the cloud, gathering layers until it's too weighty for the updrafts to support. Next time you hear the clatter of hail against your window, you'll know the fascinating journey those ice pellets have undergone. Stay curious and safe.